Hello there, this is Professor Eckhouse, and I'm going to talk today about rational equations. So far we've only talked about expressions, which doesn't have an equal sign. You're not solving for anything, you're just simplifying. Today, we're going to talk about how to solve for an x that's buried in one of these very complicated looking rational expressions. So we're going to look at clearing denominators, and we're also going to look at, towards the end, extraneous solutions. So sometimes you'll get solutions that are not actually a solution. And then we're going to look for specific variables and how to solve those. We are not going to cover, these are in the book, but we are not going to cover proportion, variation, work, or concentration problems that would have made this lesson far, far too long. All right, so let's first look at solving rational equations by clearing denominators and what the steps are. So the first thing is you're going to find the least common denominator of all the rational expressions on each side. So you're looking at, right, this is an expression, and then this is a different expression, right? And they're set equal to each other, which means it's now an equation. We're going to find the least common denominator, and then we're going to multiply both sides by this least common denominator. But the thing is today, instead of using, in this case, it would be the least common multiple of these two numbers is 56. So let's say least common denominator or least common multiple of 8 and 7 is 56. But that's really just 8 times 7. And so let's leave it as 8 times 7. And you're going to find that leaving it like that is going to make all of this much simpler, especially as we move into more complicated denominators. All right, so let's start by thinking about how we're going to multiply both sides of this thing by that least common denominator and why. So I'm going to multiply both sides. Let's start, I'm going to do this one step at a time, by 7. So multiplying this by 7 means I really should put this x plus 1 in parentheses because I'm multiplying the whole thing by 7. When I do that on the right side, what cancels? So that 7 is going to cancel on the right side, and that was the point, right? And so then we're going to multiply also both sides by the 8. So by the 8 right there. And that 8 is going to cancel there, but not on the right side. So I've kind of made a mess. So let's try to straighten this out. So let's rewrite it. So I would not try to work from that point right there. So write a little bit more. And over on the right, you're going to get, and don't miss this negative right here. So we've got a negative 5 times 8. Okay, so negative 5 times 8. All right, so now let's combine like terms and simplify this, and we just need to solve for x. So the denominator is gone, and now it's just a basic algebra equation. So we've got 7x plus 7 equals negative 40. All right, so now we're going to subtract 7 from both sides. Be careful with the negatives. Negative 7 equals, think about it, what is it? Negative 47. I forgot the x. Oh, sorry. I'm going to fix that. Fix that. Back up a little bit. This cancels out. I get 7x equals negative 47. There we go. All right, so 7x equals negative 47. Divide both sides by 7. And I get x equals negative 47 sevenths. And it is okay to have a complicated looking improper fraction. You could just leave it like that. Okay, moving on. So what are we going to do with this one? So what you're going to find is there's so many different kinds of problems that you have with these. I'm just going to try to throw a whole bunch of different problems at you. So yes, you can skip some of these examples, but you'll skip different kinds of problems that you might like to see. All right, so here we have, think about what you might need to do. We want to clear the denominator. Clear the denominator. How are you going to do that here? Well, you're just going to multiply both sides by this 9x plus 3. So 9x plus 3, and I'm going to put it in parentheses every time I do this. So don't skip that part, because when you have negatives, it can really mess you up. All right, so the 9x plus 3 cancels out, and I've got 6x equals 1 times 9x plus 3. All right, so now let's simplify this. I'm going to get the x's to the left, so I'm going to say minus 9x. It doesn't matter which side you go to, but it seems like least steps to do it that way. So I get negative 3x equals 3. I'm going to divide both sides by minus 3, or negative 3, and I get x equals negative 1. All right, so now could you check this? Let's do a little check, and I'm not going to show you this every time. The video would be way too long, but you can check these by just this normal way that you always check when you solve an algebra equation. So you'd have 6 times minus 1 over 9 times minus 1 plus 3. Does that equal 1? That's the question. So negative 6 over negative 9 plus 3, does that equal 1? We get negative 6 over negative 6, and yes, that equals 1. All right, so what you're doing is you're, of course, trying to find out if this original statement really equals 1, like it says it does over here. All right, so I highly encourage you to check your work. It will make you better at all sorts of things if you just practice doing that. All right, so what are we going to do with this one? See if you can pause the video and see if you can figure out how to do this one. All right, so I am going to say the least common denominator is going to be, of course, just 6 times 5. So it's 30, but I'm going to leave it as 6 times 5. So I'm going to multiply both sides by 6, and this 6 will cancel. And then I'm going to multiply both sides times 5, and this 5 will cancel. So what am I left with? So I would rewrite, because it's a little complicated to look at, so don't skip this part. 5x equals negative 8 times 6. All right, so I get 5x equals negative 48. Now divide both sides by 5, and you get x equals negative 48 fifths. All right, so if you're going to check that, you can just use your calculator and use the fraction button if you have one, and double check that this works out so that the left side equals the right side. All right, so moving on. Give that one a try. All right, so our least common denominator is going to be this and that multiplied together. Okay, so I'll start with the 7. So I'm going to say times 7, and I'm actually going to highlight this instead of just using colors because I think it stands out a little bit better. All right, so that 7 is going to cancel out. Now I'm going to multiply both sides, and I'm going to put it in parentheses by 5x minus 2. 5x minus 2. Okay, so remember this is over 1. Don't lose sight of that. And this has parentheses around it, so it looks the same. So now you can see that that is going to cancel out. Okay, so let's highlight this so we can really see what's going on. All right, so pause and think about that if you're confused at all. All right, so we've got 7 times 8 on the left side equals 6 times 5x minus 2. Keep it in parentheses. And you're going to get 56 equals 6 times 5x minus 2. Now, how do you solve for the x? Well, first you have to distribute is probably the easiest way to do it. So 56 equals 30x minus 12. All right, let's add 12 to both sides. So I'm going to say plus 12, and I get 56 plus 12 is 68 equals 30x. All right, so what's next? You should be dividing by 30. And the 30s cancel out, and I'm going to get x equals 68 over 30. Now that does reduce. Divide the top and bottom both by 2, and you get 34 over 15. So x is 34 over 15. Okay, so let's look at another one. Give this one a try on your own. All right, so we have 2 different denominators, and if we just multiply both sides by both of them, that will clear the denominator. So let's start by multiplying both sides by 6x. All right, so that is this one. So which one is going to cancel out? That one right there. That was the goal. And now let's multiply both sides by 8x plus 2. And again, I'm going to put that in parentheses, 8x plus 2. And I'll color it for you so you can see where it goes. All right, so what cancels? Hopefully you see that the 8x plus 2 on the right side cancels, and what do we have left? So let's write it out so we're sure we have it right. So I'm going to put the negative 1 in front of the 8x plus 2. And on the right, I get negative 2 times 6x. All right, so I get negative 8x minus 2 equals negative 12x. There are other ways to do it, but that's how I'm going to show you because it's kind of the fastest. So I'm going to add 8x to both sides. And I'm going to say -2 equals -4x. Now divide both sides by a -4. And I get x equals -2 over -4 is 2 over 4, which is 1/2. So x equals 1/2. And again, you can be plugging these in for x, putting it in your calculator, and make sure the two sides are equal. All right, so this video is going to be just a bunch of this. We're just going to do problem after problem, getting harder as we go. We're going to hit some that have extraneous solutions that I'm going to talk about. So you go at your own speed through this. All right, so this next one, we've got x plus 3 and 12. So those are our two denominators, x plus 3 and 12. So start, if you have not done it yet, pause the video and try multiplying both sides by x plus 3 and 12. So I'll start with the 12. I just do it randomly. Whichever one's shorter, I usually do first. So let's see. The 12s are going to cancel. And now I'm going to multiply both sides by x plus 3. And color code them so you can see what's going on. So the x plus 3s are going to cancel on the left side. And what am I left with? So it's kind of a bookkeeping problem. You just have to be careful. We've got 12 and x on the left. We've got -2 and x plus 3 on the right. All right, so let's distribute. 12x equals -2x minus 6. I'm going to now add 2x to both sides. I'm going to make that skinnier. Add 2x to both sides, and we get 14x equals -6. Watch your negatives. All right, next we want to divide both sides by 14. And I get x equals -6 over 14, which reduces to -2, nope, -3 over, I'm dividing both of them by 2, over 7. Right, so both of them reduced by a factor of 2. And we get -3 over 7 as our answer. All right, let's try another one. This one's a little bit different because we have a whole number stuck in there somewhere. All right, so there's a number of ways that you can do this, but I'm just going to look at the 3 and the 7. Okay, so I've got a 3 here and a 7 here, and a whole number, which is 6. I'm going to make the 6 over 1. Okay, and you can rewrite it if you want to. So I'm going to multiply both sides times 3, and I'm going to multiply both sides also by the 7. Okay, now the thing is that I want to multiply the whole side, not just the x over 3, and that's one of the biggest mistakes people make, is that they multiply the whole thing. They multiply almost only part of it. So you know what I'm going to do? I'm going to pause on taking care of that 7. We're just going to do the 3 just to keep it from being too complicated, because I'm going to have to distribute this across here and here. Okay, so let's do this one step at a time. So I've got 3 times x over 3, and that's 3 over 1, plus 3 times 6. And I don't really need to put the 6 over 1 because I'm not multiplying by a fraction. So I'm just going to delete that over 1 because I don't have to think about it. It's just 3 times 6. So again, there's many ways to do this. You can think of it however you want. On the right, I'm going to put the 3 over 1, so I remember that the 2 and the 3 are multiplied to make 6 over 7. Okay, and I'm looking at my notes. I did it totally differently in my notes. I do it different every time I do it. It just depends on kind of how you feel about it and what seems easier to you in that moment. In this moment, I decided it would be easier to do this one step at a time, and I'm going to still have a 7 left over there that I'm going to have to deal with. Okay, so now I get the 3's here are canceling out, and I get x plus 18 equals 6/7. All right, now I need to get rid of that 7 just to keep our lives simpler. And again, you could subtract the 18 and work from there, but I'm just going to show you how to do this. So I'm going to say times 7 and this whole thing times 7. All right, so now I get 7x plus 18 times 7. I did not do ahead of time because I just decided to do this at the last moment. So 18 times 7 is 126. All right, and the 7's cancel here, and I get 6. All right, so now I'm going to subtract the 126 from both sides. Minus 126, minus 126, and I get 7x equals negative 120. Now I'm going to divide by 7, and I get x equals negative 120 over 7. And the negative can go out front also instead of in front of the 120. All right, so I will repeat. There are many ways to do this. You could have done what I started to do, which is just multiply the 3 and the 7 at the same time. The reason I decided not to do that is to back off and do it one step at a time was because I see that people get lost in that and they forget to write certain things down and they make lots of mistakes. So this might work better. All right, let's move on. So in this, I have a question for you. What must x be? The 5's are the same, which means that the x must be 2, right? X must be 2. So if the denominator is the same and they're equal to each other, then the numerator must be the same. All right, so let's talk about excluded values and extraneous solutions. So excluded values are the ones that make the denominator equal to 0. Okay, so sometimes we're going to get some answers and we have to look back and go, ooh, no, it can't be that, right? Because it would make the denominator 0. So that's not a possible answer. All right, so we're going to find the excluded values and then we're going to solve the equation and reduce any fractions. Okay, so those are the steps here to this one. So what are excluded? What can x not be? In other words, what is not in the denominator? Let's write that, the domain. What is not in the domain? Well, we did that in the last video, and that is when x, so the domain is going to be where x minus 4 is not equal to 0, right? So x cannot be equal to 4. Important. If I put 4 in there, I would get 0 in the denominator. So that's the first step, is just to keep track of that. All right, so let's start working on how to solve this problem. What would you do first? Should I cross multiply? Yeah, you could, but you're going to have a big complicated thing. And why would you? Because we just said right up here that if the denominator is the same, then the numerators must be equal. So in this case, the denominator is the same, which means we can just say that 5x minus 1 is equal to 34. And we have taken care of a lot of math that we don't have to do now. Right, so add 1 to both sides, I get 5x equals 35. Divide by 5 and I get x equals 7. Okay, so x equals 7. All right, so we found that it couldn't be 4, but that's okay because we didn't find 4 as an answer. But if we did find 4 as an answer, there would be no solution, right? Because that could not be a solution to this, right? So let's move on and think about some others. All right, so let's solve this equation. What are we going to do first? So let's think about what x cannot be first. Okay, so x cannot be 5. Because if I plugged 5 in right here, I would get 5 minus 5, and that would be 0. So x cannot be 5. First step with these kind of equations. All right, so now the denominator is the same. So that means the numerator must be equal. So that means 25 equals x squared. So let's solve that problem. So let's take the square root of both sides, and we get, and I'm just going to switch, we get plus or minus 5 equals x. Plus or minus 5. In other words, x could be 5, or x could be negative 5. Right? Because if you put negative 5 in there and square it, you'll get 25, and if you put 5 in and square it, you get 25. But we just said that one of those are not possible. It's excluded. Right? So x is excluded. I'm sorry, 5 is excluded. 5 is excluded, which means this is not a possible answer, and there is only one solution that works, and that's x equals negative 5. Okay, so sometimes you will have excluded answers, and you have to be aware of that. So be careful and think about what, or maybe write down at the very beginning of the problem, what you know x cannot be, even if it's not asked for. All right, so a quick summary of solving rational equations. First, find any excluded values. That's the values that make the denominator equal to 0. Then find a common denominator. If the denominators are equal, the numerators must be equal. Set the numerators equal to each other and solve. Or multiply both sides of the equation by the LCD of all the fractions and solve. Okay, so first check and see if the denominator is the same. And if it's the same, you don't have to go through finding the LCD. All right, last, when reporting an answer, be sure not to include extraneous solutions. Okay, so that's your summary. All right, you can pause the video and write all that down if you would like it in your notes. All right, so the last topic is rational formulas. We're going to use algebra rules to solve for unknown variables. So this is very different than what we just did, but it's still working with manipulating things using algebra. So work can be modeled with this formula right here, where the amount of work done, which is W, is the product of R and T, right? So that's what the formula tells us. So find the equation for time. All right, so we've got W equals R times T. So find the equation for time. That means time needs to be isolated. In other words, isolate the T. So how would you isolate the T? Well, you just need to divide both sides by something. What would that be? And a lot of people say the T. Well, then T is going to end up on the bottom and it won't be isolated. You want it isolated. How are you going to get it by itself? You're going to divide by R. Okay, so now the new formula is T equals W over R. Okay, so that's our formula for time. So now you do the one for the rate. The product of the rate of work and the time spent needs to be rearranged. So we're looking for rate. So W equals R times T, and this time we are looking for R. So what you need to do is divide both sides by T. The T cancels, and we end up with R equals W over T. Okay, so let's try another one. The formula for density of an object is D equals M over V. D is the density, M is the mass, V is the volume. Find the equation for mass and find the equation for volume. So try pausing the video and see if you can find those equations. All right, so we've got D equals M over V, and we want the equation for mass. So we want mass by itself, so what are we going to do? We're going to multiply both sides by V, and we get the V's cancel, and we get M equals D times V, or V times D, however you want to write it, it doesn't matter. Okay, so that's the equation for mass. Find the equation for volume. All right, this one is just a little bit harder. So you want V to be I'm trying to highlight it, V to be isolated. So we don't want it on the bottom though. We want it on the top and by itself. So first step is, in this case, we do want to multiply times the thing we're looking for because it's on the bottom and it needs to be on the top. Okay, so we're going to cancel that, and this is going to be a two-step problem. So we've got V times D equals M. We are still looking for V, volume. So now we're going to have to multiply both sides by D, and the D cancels, and we get volume equals mass over density. Okay, so why would we do this? We would do this because sometimes you have scientific notation or you have a bunch of units and you have all sorts of things to keep track of. So if it's already rearranged before you stick your numbers in, it often will keep you from making mistakes. So just rearrange the formula first and then plug your numbers in. It helps a lot with physics and chemistry class as well. All right, here's another one for you. The formula for the volume of a cylinder is given. Find the equation for height and find the equation for radius. So pause the video and give these a try. All right, I'm going to write these down so I've got them right where I need them. So start with what you're given and then maybe highlight or underline what you're looking for. So I'm looking for h. So that means in one step, all I have to do is divide both sides by pi r squared. Pi r squared, the pi cancels, the r squared cancels, and I have a new formula for height. Height equals, what's left? I'm just changing sides, so think about what you've got left on the left side. So you've got v over pi r squared. All right, so that's our new formula for height. All right, on the last one, how are you going to solve for radius? So it is with two things. They're not side by side, but it doesn't really matter because multiplication is commutative. You can change the order of it anytime you want. So I'm going to divide both sides by pi and h. So the h cancels and the pi's cancel. And I get r squared equals v over pi h. But we weren't solving for r squared. We want to solve for r. So we're going to square root both sides to get to the r. And now we've got r equals the square root of v over pi times h. And that is the final answer on that one. All right, we have, I think, one more. So the area formula for a trapezoid is given right here, where a and b are the two parallel bases and h is the height. So a trapezoid looks like something like that. Something like that. And this would be maybe the smaller base, and this is the bigger base, and this is the height. Okay, so that would give us the area, the formula for the area. So we're supposed to find the equation for the base B. So pause the video and see if you can figure it out. Okay, so we're trying to get B out of there. So I'm going to highlight B so I don't forget what I'm doing. So the first thing I want to do is kind of think about peeling away the layers. Okay, so the first thing we're going to do is take away that H, get it to the other side. So now I have A over H equals A plus B over 2. So I'm still trying to get to that B, so I'm going to multiply both sides times 2. And I get 2A over H equals A plus B. Now what am I going to do to get the B by itself? Isolate it. Well, I'm just going to subtract A. Subtract A, and I'm going to rewrite this over to the right a little bit. So I've got 2 big A, the area, over H, minus the leg length A equals the leg length B. And that's the formula to find B. Now see if you can figure out how to do the one for height if you haven't done it yet. All right, so we're going to have A plus B over 2 times H. Now, remember, if you're trying to get rid of a fraction, so let's just say that I had a formula x equals 1/2 y. How would I get y by itself? Well, I would multiply by the reciprocal. Whoa, terrible 2. Let me try that again. 2 over 1. So I'd multiply 2 over 1 on both sides, right? And then this goes away. No matter what numbers they are, even if they weren't ones, they would go away. So let's think about that. What if we multiplied both sides by 2 over A plus B? It's the reciprocal, so everything cancels. 2 over A plus B, multiplied by that. All right, so now let's show it cancels. The 2's cancel, the A plus B cancels. And I'm left with H equals A times 2 over A plus B. And another way to write that would be 2A over A plus B. Because remember, A is just over 1. All right, so that's our final formula for that one. I believe that's the end. All right, thank you for watching. A lot of examples there.